In this section, we will learn about a new concept related to functions, which is inverse function. The description of this objective is found in the book on page 193. Consider the functions fx equals x plus 1, which is the first function, and gx equals x minus 1, which is the second function. If f is followed by g, which is the shape of the composite functions as shown in the figure, then whatever number is input is also the output. Let's observe the first input is 2, the overall output is also 2. This means that f is followed by g. These two numbers will always be the same, whatever the input. Here the input is 2, the overall output is also 2. If we apply the rule of 2, the result will be g of 2, since the first input is 2, which is equal to g 2 plus 1, since fx equals x plus 1, which is equal to g of 3. Substitute x equals 3 in gx equals x minus 1, which is g of 3 equals 3 minus 1 equals 2. Therefore, g of f2 equals 2. We observe that the input is the same as the overall output. If x is the input, then x is also the output. If we have to find the value of g of x, then first we can deduce that fx equals x plus 1, thus g of fx equals g x plus 1. Now we have to substitute the x by x plus 1. It becomes g x plus 1 equals x plus 1 minus 1 equals x. Therefore, g of x equals x. In this case, the two functions f and g have a special property. This composite function, once given an input, it will produce the same output. Therefore, the two functions f and g are called inverse functions. The function g is called the inverse of the function f. The inverse of f is the function that undoes whatever f has done. This means that since g is the inverse of f, it undoes whatever f does, so the value of the output will be the same as the input. The notation f minus 1 is used for the inverse of f. So instead of writing g, we write f minus 1, which represents the inverse function of f. Let's look at the sketch on this. If the input is x, the function f gives a function fx. For the inverse function, it takes fx and undoes whatever it has done to give the same output. To conclude, the inverse function is the function that undoes whatever f has done, which means to give the same input as the output. Let's take an example, fx equals x plus 1. Note that graphically, the inverse of f, which is x minus 1, is a reflection of fx in y equals x. The special feature of the inverse function is that it is a reflection around y equals x. Thus, we take it as a mirror. Since fx is y equals x plus 1, the inverse will also be on the opposite side. So it has the same property, parallel to y equals x, and has the same distance from y equals x. So we have grasped the definition of the inverse function and its role. We also explained the graphical representation of the function and its inverse.